don't need to explain it. The purpose of electric fuse or purpose of using electric fuse.
Corona, please. Ma'am, when the bulb stand hot, ma'am, then it is fuse.
Why we use the electrical fuse? Okay, anyone else in the class who can tell me the answer? Just simply in short, but why? What is the purpose of using the electrical fuse? Why we use the fuse? Brito Bruto Shatra, you have raised your hand. Yes, Brito Bruto.
Ma'am, the purpose of using fuse, ma'am, because sometimes in high voltage, it helps us to automatically shut down the our home areas electricity.
Okay. Okay, you're very close. Your answer is very close. So what happens? I'm again telling you. Okay, Anibo has also raised the hand in between. Yes, Anibo.
Ma'am, the fuse is a safety device, and ma'am, when ma'am, it is used in between the switchboard and the electrical appliances, and when ma'am, the overflow of current will flow through that wire of the fuse, it will break automatically because that can't load any overflow of electricity. That wire that is there in the fuse, and that's why we use
Okay,
fuse.
very good. Very good. That is the correct answer. So in our daily life, we use many different types of electrical appliances in our kitchen, in our rooms, when we study. Now also we are using the laptops and mobile phones. So many different types of different types of electrical appliances we use. Almost we are completely dependent on the electrical appliances. We use the electrical current so much. But what happens? Not all the appliances can hold or can use the same amount of electrical current. Okay. So what happens if the current of it that is beyond its the amount of current is beyond its resistance? So any electrical appliance, what is actually the capability of that electrical appliance to hold the power? If the electrical current or much more electrical current enters the appliance, then what happens? It catches fire. It gets heated up very quickly, and then due to that heat, it catches fire. And from that appliance, any particular thing in our home, like curtains or anything that we use that can catch fire very easily, that will also catch fire. So our house can catch fire. So to avoid these kinds of accidents, so this is why we always use the electric fuse. It's a safety device. That's absolutely correct. So how it saves us? Because the electric fuse is generally created. It is placed in between the switchboard from where the electric current will come and the appliance, electrical appliance. It is present in between them. So when much more of electrical current will enter the wire, enter the electrical fuse, what will happen? There is a particular capacity of that fuses. So when it will enter, when much more amount of electrical current will enter that electrical fuse, the wire will automatically melt. And when the wire will melt down, what will happen? The circuit will be broken. So to get the proper work or to get the proper result that we want, we always need to make a complete circuit. If the wire present in the electrical fuse, it melts down, then that means the circuit is broken. When the circuit is broken, that means the electrical current that cannot reach the electrical appliance. So the appliance will not work, the appliance will not get heated, it will not create the fire, and we will be safe. So this is how the electric fuse helps us. It saves us. So it's a safety device. The fuse is a safety device that makes use of heating effect of electrical current. So this is how we can use the current. It is often used in household and building circuits to protect us, to protect our appliances. It prevents them from getting burnt out in case of excess current flows through the circuit. The fuse consists of an alloy of low melting point, and it is fitted into the carrier made of porcelain glass. Why it is made of porcelain glass? Because so porcelain glass is an insulator, right? It will not carry the electrical, it will not conduct the heat as well as the electricity. So there is a covering of an insulator outside the outside the metal wire that we use in making the electrical fuse. And the wire must be of a very low melting point, so that when there will be an overflow of current through that wire, the wire will melt immediately. The heat produced due to the high current quickly melts the fuse wire and it breaks the circuit instantly. Thus, the current flow will stop and it will cause no damage to the appliance. Now, most of the electrical appliances are very much expensive also, most of them. So it will help them, it will help us to save our electrical appliances from such damages. So the damage is avoided, and there can be by this due to this heating effect, that appliance can catch fire also. So it helps the appliance, it helps to stop the damage of that appliance. Now it has to be, once the wire is broken, it cannot be rebuilt. Okay, we need to replace it with a new piece of same kind of wire, and it should never be replaced by a thicker wire. Okay, if it is replaced with thicker wire, then what will happen? The electric current, when there will be an overflow of current, the current will very easily flow through it. Though there is an electrical fuse, but it will not work, the appliance will be damaged. So next time, after melting off a particular type of wire, next time when we will replace it, we will have to replace it with the same kind of wire. Nowadays, another device known as miniature circuit breaker, MCB, which is used in the household circuits, that breaks or go off automatically on being heated up by the overload of electrical current. MCBs can be reset by hand, or the circuit becomes complete again. So here you can see a picture of MCB. The miniature circuit breaker is given here in your book. I'm zooming this part. You all have seen these MCBs. Nowadays, we prefer to use MCBs. Why? Because why we prefer to use the MCBs? Because it will cut off the current, it will cut off the connection, it will cut off the circuit immediately and automatically. Okay, so we prefer to use these right now. You have seen this in your homes and in your school or in other buildings, wherever you will go nowadays a lot. Now go to the next page. Let's see what is the next topic here. Only 4 students have turned on the video. Junaid Mondol, Ritobroto, Sheikh Sahil. Okay, now that's good. So why do you turn off your video? What is the need of turning off your video? You just turn on the video, fix the camera and sit. If you have any doubt, you can ask me. Next topic is magnetic effect of electrical current. So by using the electricity, we can also create magnets. And you have done that project in science exhibition also. I've seen it. There were most probably two projects were there, where you have used the electrical current and you have made magnets by using it. Let's see how we can do it. We know that the needle of a magnetic compass is a tiny magnet, which points in north-south direction. When points, we bring a magnet close to it and the needle gets deflected. Okay, now it is visible. A Danish scientist named Hans Christian Ørsted, he was first person who noticed this magnetic effect of electricity. And he was the first person who was able to use it in compass, who was able to use this needle, which has the magnetic characteristics, and how that the compass needle, every time the current was the change of the compass needle, every time the current was passed through the wire. This came to be known as the magnetic effect of electric current. You can demonstrate this effect by performing an activity. So we can make magnets using electric current, using the current or electricity. And this is how we can make it, how we can make the magnets using electricity. That is given in this following activity box. You can see, by performing this activity, you can do it yourself. But always make sure that you should maintain all the precautions while during performing this activity. What is the aim of this activity? Let's see, I have zoomed in this part. You also open that page from your book and read this part. That what is the aim of this activity? The aim is to show the magnetic effect of current. How we can create magnets by using current. What are the materials that you will need? You will need a cell, you will need switch, connecting wires, and magnetic compass. Okay, these are the things, these are the materials that you will need to perform this activity. What is the method? How we can make the magnets using electricity? So make a circuit shown in the as in the figure using the connecting wire, switch, and the cell. So if you have the switch, if you have the connecting wire, what we call conductor or conducting wire also, and if you have the cell, then you can easily make the circuit. You can easily make an electrical circuit. How to make it? You have read it in detail previously in the same chapter. So I'm not telling it again. So you will have to make a circuit. Here you can see the circuit is made. Here you can see, I'm just zooming in this part. Can you all hear me?
Yes, ma'am.
Okay, because I got disconnected for a few seconds. Suddenly I got disconnected. This is why I was not sure you can hear me or not. Because I am telling it continuously, but if you can't hear me, there will be no use of it. Okay, so let's see. I'm sharing the screen again. So picture A shows us how to make a complete circuit. Okay, and picture B shows us that how we can make a magnet by using the electric current. So let's see what is written here. So make a circuit as shown in the figure using the connecting wires, the switch and the cell. Place the magnetic compass near the wire and put the switch in the open position to let the current flow through the circuit. What do you observe? After that, what will you observe? You will observe that the needle of the compass gets deflected from its resting position. That means it is in kind of movement. Gets deflected means it is changing its position. It was in the resting position, but if you bring that magnetic compass in front of the circuit through which now current is flowing, then you will see suddenly the magnetic compass, which was in resting position, it will start moving. Okay, when we switch it off, then the compass needle again comes to the resting position. Okay, so we all know that in the compass needle means, you all must have seen the compass. Have you seen the compass in keychains or key rings? Also compass is available right now.
Yes, ma'am.
So
Pencil
it
compass.
has one needle.
Yes,
This is called needle. Okay, this is called this diamond shaped thing that indicates the direction. This is called the compass needle. Okay, so there is magnet inside it. That magnet shows us the direction, north and south, right? You have learnt it in magnets, in the chapter of magnets, that magnets are used for in the compass to show us the direction, north and south. Now these magnets are attracted by the electric current. So how this thing we can just prove by this activity. So when you will bring this compass needle in front of an open circuit, so in front of a circuit through which the current is flowing, you will see that the compass will automatically start moving. But when you turn it off, when you switch it off and the current will not flow through the circuit, then the compass will again come to its resting position. It will not move. Again, you switch it on, current will flow and the compass will start moving. Again, you switch it off, the compass will stop moving. It will come back to the resting position. So what is the result? This is the observation. And what is the conclusion of this experiment? So this is what you can observe. But after observing this thing, what is the conclusion of this experiment? The conclusion of this experiment is that whenever any compass is brought very close to any electrical circuit, active electrical circuit, the magnetic needle gets deflected when electric current flows through that electrical circuit. So whenever electric current flows through the electrical circuit, the magnetic needle or any kind of magnet, it will get deflected. Magnetic needle and compass, it will get deflected. It will start moving. Okay. So in by following the same thing, by or the same method, we can also make electromagnets. So can anyone tell me that? Do you have any idea what are electromagnets?
Ma'am, the
Electromagnets.
magnet that are formed by the electricity.
The magnets that are formed. Yes.
The magnet which works on electric. Ma'am, while giving electric, the magnet works.
Yes.
No, ma'am.
Both of you are correct. Why? Because we make the magnets by using electricity. Okay. We make the magnets. That means we can turn any metal into magnets by the application of electricity. Okay. Yes, Anibu,
Yes.
you want to tell anything?
No, ma'am, nothing.
Okay, okay. Is there any doubt in your mind? You can tell it.
No, ma'am, okay.
Okay, okay. So we can turn any metal into magnet if we apply electricity by the use of electricity. Then that magnet will be called an electromagnet. So let's see what is written, what definition is given in your book about electromagnet. When electric current flows through a wire wound around an iron bar, the bar behaves like a magnet. This magnet is called the electromagnet. See the same thing. So when we wrap an iron bar with a copper wire, and we just flow electrical current through that wire, then after some time you will notice that the iron bar will also act as a magnet. So temporarily the iron bar has converted into magnet. So these types of magnets that are produced by using electricity or electric current, they are called the electromagnets. An electromagnet is formed due to the magnetic effect of electric current. It loses its magnetism as soon as the current stops flowing. So whenever you switch it off, the current will stop flowing. It will again become the iron bar. It will never be the magnet anymore, right? So what is magnetism? There is a new term that we have seen, magnetism. Can anyone tell me what is magnetism? What is magnetism? Any of you who are present in the class, tell me magnetism. The ability of any magnet or the ability of any material to attract another material, right? The ability of any material, or you can also say any magnet, the ability or power of any magnet to attract some other metal or material towards it, that is called the magnetism, right? So whenever you will switch it off, that means electric current will not flow through the wire, then it will become or turn into iron bar again. It will not remain as, it will not act as a magnet. So this is the particular characteristic feature of the electromagnet. Okay, it creates the magnetism. It creates the magnet for a for a particular time period when when the switch is in on mode and the current is flowing through the wire. Okay, so it's a temporary magnet. Okay, not permanent one. The magnetic material around which the coil is wound, it is called the core, and the core increases the magnetic effect of the solenoid several times. So what is solenoid? A solenoid is a device which can be used as an electromagnet. It is made of a long wire that has been wound many times. So the wire, the device that has the wire, that will be called the solenoid, and the iron bar around which we will wound up the solenoid or wound up the wire, we will wrap the wire, that iron bar will be called as the core. And after we will flow electric current through the solenoid, and then the core will be converted into electromagnet. Is it clear? So what we will have to do, we will have to take an iron bar, that means a simple short rod of iron, and we will have to wrap it with a wire, copper wire. The device that contains the copper wire and that is responsible for the flow of, that will conduct the flow of electricity through the copper wire, that is called solenoid. Okay, and the iron bar or iron rod we are using, that will be called the core. So when we will wrap the iron bar or core with the solenoid or copper wire, and we will just switch it on, and the electric current will be allowed to flow through the copper wire, then the iron bar or core, what we call the core, temporarily it will be converted into magnet. It will show some magnetic power. So at that time, that iron bar or core will be called magnet. But when you will switch it off, electric current will not flow through the solenoid, electric current will not flow through the wire. Then what will happen? It will again become a core. It will again become a simple iron bar. Okay, it will not be electromagnet at that time. Is it clear? This is very basic concept of electromagnet. Is it clear? Or if any doubt is there, you can tell me.
No, ma'am, no doubt.
Ma'am, no doubt.
No, ma'am, no doubt. That's very
No.
good. You read this part. Okay,
No, ma'am, no doubt.
electromagnet. Simple thing, but it's very interesting, and at the same time, there are many.
There are many applications of these electromagnets. Okay, so we will learn about it in the next class. I will not tell you tomorrow because the class time is almost over, right? So that's it for today. Just mark up to the electromagnet.